Here we have a 3 by 3 matrix, and we want to show that a squared equals to 4a plus 5. That is, we want to show that the left hand side is the same thing as the right hand side. Now to do this, let's simplify a squared. A squared is the same thing as saying a multiplied by a. That is, we want to multiply this matrix twice, and that is going to be 1, 2, 2, 2, 1, 2, 2, 2, 1. Multiplying itself is going to be that you want to repeat this, which is 1, 2, 2, 2, 1, 2, 2, 2, 1. Now, to multiply this, there's something we call row by column multiplication in matrix. That is, the first row is going to multiply the first column. The same thing for the next one, the first row multiplying the second column, and this is going to be repeated. Now what I want to do now is to use my first row to multiply my first column. And to do this, it means 1 multiplied by 1 is going to be 1, plus 2 multiplied by 2 is going to be 4, plus 2 multiplied by 2 is also going to be 4. So we are done with this first line. We're done with this. Now we want to use this also for the next column. Repeating this for the next column, here we have 1 multiplied by 2. We still have 1. 2 multiplied by 1, we have 2. 2 multiplied by 2. Here we have 1 multiplied by 2, which is 2, plus 2, plus 4. And for the last one, we want to use this row to multiply this column. So which is going to be 1 multiplied by 2 is 2, 2 multiplied by 2 is 4, and 2 multiplied by 1 is what? Is 2. So we are done with the first row. So what I did here is to use this to multiply this first column, use this same row to multiply the second column, and use this same row to multiply the last column. Now I'm going to do the same thing for the second row. So I'm going to use this second row to multiply this column. Now 2 multiplied by 1 is going to be 2. 1 multiplied by 2 is going to be 2. 2 multiplied by 2 is going to be 4. So I'm going to do the same thing here. So 2 multiplied by 2, which is going to be 4. 1 multiplied by 1, which is 1. 2 multiplied by 2, which is 4. And also for the last one, the same row multiplying the same column. Here I'm going to have 2 multiplied by 2, which is 4. 1 multiplied by 2 is 2. And 2 multiplied by 1 is still going to be 2. Now for the last row. So I'm going to use this last row to multiply this column and also this column and the last column too. Now 2 multiplied by 1 is going to be 2. 2 multiplied by 2 is 4, and 1 multiplied by 2 is 2. And here the same thing. Here we have 4. 2 multiplied by 2, which is going to be 4, plus 2 multiplied by 1 is 2, and 1 multiplied by 2 is 2. And for the last one, I'm going to have 2 multiplied by 2, 4. 2 multiplied by 2 is 4. And last one, I'm going to have 1 multiplied by 1 to be 1. So here I can say that my a squared is going to be 1 plus 4 is going to be 9. 2 plus 2 plus 4 is going to be 8. 2 plus 4 plus 2 is going to be 8. And for the next row, here I'm going to have 8, 9, 8. And for the last row, I'm going to have 8, 8, 9. Now if you look at this, you can see that the row here, the diagonals here are 9 and the off diagonals are 8. So this is a squared. And this is what we want to show that, okay, 4a plus 5 should give us the same thing. 4a plus 5 should give us the same thing. This is our objective. Now to do this now, we have our 4a. This is scalar matrix multiplication. scalar matrix multiplication. And then to get our 4a is going to be 4 multiplying the matrix A, which is 1, 2, 2, 2, 1, 2, 2, 2, 1. If we multiply this out, here we should have 4, 8, 8. That is 4 multiplied by 1, 4 multiplied by 2, and 4 multiplied by 2. The same thing, 4 multiplied by 2 is going to be 8, 4 multiplied by 1 is 4, and 4 multiplied by 2 is going to be 8. And here we have 8, we have 8, and here we have 1. Now, what about 5? Here, we can say that your 5 is multiplying an identity matrix. Okay, let your 5 multiply an identity matrix. And how do you put an identity matrix? It's like you saying that we have 5 multiply your identity matrix of 3 by 3 matrix. That means the diagonal are going to be 1 and the off diagonals are going to be 0. This is how it looks like. And if your 5 is multiplying this, here we're going to have 5, 0, 0, 0, 5, 0. The off diagonal are going to be 0 and the diagonal are just going to be 5. So now, don't forget that we have 4a. We have 4a plus 5. And the 4a is 4, 8, 8. 8, 4, 8. 8, 8, 1. Plus 5i, which is going to be 5, 0, 0, 0, 5, 0, 0, 0, 5. If you take a good look at this, this matrix, you should have 4 plus 5, which is 9. 4 plus 0, 8 plus 0 is going to be 8. 8 plus 0 is going to be 8. Please, you can check my other videos on the playlist on how to do this. The addition of matrix has been explained in my playlist. Okay? And here we have 8 plus 0, here we have 8. 4 plus 5, we have 9. 8 plus 0, we have 8. And for the last one, 8 plus 0, we have 8. 9 plus 0, we have, 8 plus 0, we have 8. And 1 plus 4 plus 5, sorry please, this should be 4. 4 plus 5 should be 9. This should be 4 because 4 times 1 is going to be 4. So 4 plus 5 is going to be 9. Now let's confirm this and a squared. You can see we have 988, 988, 898, 898, 889, 889. So what I just did was to do 3 by 3 multiplication of matrix, which I got this, and I simplified it to be this, a squared. And here we have 4a plus 5. I multiply my scalar with the matrix A. This is what I did here. And I got 488, 848, 884. This is what I did. Plus 5. So instead of using this 5, then we can say that we have 4a plus 5 times the identity matrix. And the identity matrix of a 3 by 3 matrix, it means that your diagonals are going to be 1. And your off diagonals are going to be 0. That is an identity matrix. So if you multiply it, so you only have 5 on the diagonals. So this is what you have. So when you add it to the 4a, So you will get the same thing as a squared. Thank you very much for watching. Please don't forget to subscribe, like, and share this video. Thank you.